Welcome to this explainer on public roadmaps and the atomic scale bottleneck. Today, we're doing things a little bit differently. We are completely bypassing the marketing hype, the flashy press releases, and the polished startup pitch decks. Instead, we're going straight to the source. We're looking directly at the semiconductor industry's most respected public roadmaps. Why? Because if you know how to read them, these documents quietly reveal the industry's next massive structural bottleneck. Look, whether you're an investor deep in due diligence, or a semiconductor fab mapping out your next-gen facility, understanding this atomic scale bottleneck and exactly how to resolve it is absolutely crucial.
Here is our agenda for today. We're going to cover the unvarnished industry signal, IMOC's logic technology trajectory, IRDIS and proactive contamination control, the looming atomic scale bottleneck, and finally, SisuSemi's atomic level purification.
All right, Section 1, the unvarnished industry signal.
Let's start by establishing exactly why we're obsessing over these specific documents. Honestly, to the untrained eye, these roadmaps can seem like incredibly dry, dense, highly technical reading. But you know what? That is exactly what makes them the most valuable tools for anyone doing serious due diligence in this space. Roadmaps are literally the least typed documents in the industry. Think about it. Nobody's trying to raise venture capital off a roadmap. They're written by research consortia and standards bodies for an audience of incredibly strict engineers who will hold the authors accountable for every single claim. There's zero fluff. And if you read enough of them in sequence, this perfectly clear pattern emerges. They expose exactly what the industry is quietly planning for, and maybe more importantly, what they're quietly terrified of.
Moving right along to Section 2, IMOC's logic technology trajectory. Let's see how this all builds. Now, if you follow the semiconductor space, you already know IMOC's research basically draws the physical blueprint for our future device architectures. There is this extreme, relentless push towards sub-1 nanometer gate lengths right now. And the industry is doing this simply to overcome short-channel effects that are capping conventional silicon. Just look at the progression we're on. We're moving from today's gate-all-around and nanosheets straight towards complementary FET or CFET architectures, which shrink the cell footprint by stacking devices vertically. And eventually, we arrive at 2D channel materials using completely wild stuff like atomically thin tungsten disulfide and molybdenum disulfide. It is a genuinely exciting architectural shift, but it runs headfirst into a massive materials problem. Because the roadblock here isn't physics, it's materials. In IMOC's own published work, they explicitly name channel material quality and control of defectivity as the primary pacing items for the next generation. I really want you to stop and notice the order here. Interface quality and defectivity are put ahead of contact resistance. They're ahead of device physics modeling. They are even ahead of lithography, and that's while they're actively pushing toward high-NA EUV and flagging its own defectivity issues. It is literally the industry's own research arm screaming that surface quality is their biggest obstacle.
Now for Section 3, IRDS and proactive contamination control.
To see the full picture here, we've got to align IMOC's trajectory with another major consensus document. That's the IEEE's International Roadmap for Devices and Systems, or the IRDS. We specifically want to look at their yield enhancement chapter. The IRDS roadmap treats defect prevention and proactive contamination control as this massive, cross-cutting concern. It touches front-end process technology, interconnects, lithography, metrology, all at the exact same time. And this reflects a really harsh physical reality in fabs today. A defect or a contaminant at the atomic interface doesn't just stay contained to one step. It propagates. It multiplies like a virus through every single process step built on top of it, completely destroying yield. Which creates a very dangerous asymmetry in today's fabrication plants. On one hand, we have a rapidly tightening defect tolerance. Because as critical dimensions shrink, the size of a defect that can completely ruin a device shrinks right along with it. But on the flip side, our detection tools are absolutely straining. The industry's ability to actually detect and characterize these defects at the atomic scale is becoming proportionately harder and harder. So our tolerance for contamination is shrinking, while our tools to even find it are struggling to keep up. Honestly, that is the textbook definition of a structural bottleneck.
That leads us to Section 4, the looming atomic scale bottleneck.
So, what happens when we take a step back and lay IMOC's architectural trajectory directly on top of those IRDS yield warnings? Put them together, and it becomes an unarguable, rock-solid fact that atomic scale interface quality is the industry's next major structural bottleneck. Think about it. The IMOC device roadmap is barreling toward architectures like stacked CFETs and atomically thin 2D channels that have vanishingly little margin for surface and interface defects by design. There is simply less physical material for a contaminant to hide in. Meanwhile, the IRDS yield roadmap is flat out telling us that contamination control is already a standing, cross-functional crisis at today's dimensions, long before we even fully deploy those next-gen IMEC architectures.
And this is the crucial takeaway. The industry has publicly broadcast to everyone, in their own consensus documents, the exact problem that needs solving. They've spelled out the requirement perfectly, but what they absolutely haven't done is hand anyone the answer. They intentionally leave the solution space wide open. And that right there is exactly why this specific area is a goldmine for investors and technical partners to watch.
Which brings us to the most important question for anyone with a stake in the future of semiconductor manufacturing. The industry named the problem, so who actually has the solution? Because we know for a fact that trying to manage around this with just incrementally better particle-level cleaning from the last generation, it's just not going to work. That's not enough for 2D materials. So who is stepping into this void with a real, viable solution?
And finally, Section 5, SisuSemi's atomic level purification.
This brings us directly to the layer where SisuSemi operates, and exactly why their technology is so perfectly positioned for this specific moment in the semiconductor timeline. See, SisuSemi doesn't just do traditional particle cleaning. Their ALP platform, atomic level purification, is fundamentally built to resolve the root causes of these interface defects. It directly tackles the atomic level ordering and contamination at semiconductor interfaces that those roadmaps are screaming about. And crucially, it delivers this in a form that is entirely compatible with the very device architectures, the CFETs and 2D channels that the industry is already financially committed to building. They are delivering the exact atomic level ordering that the roadmaps are demanding.
And what you really need to take away from this is that SisuSemi isn't just reacting to these documents after the fact. They didn't read the roadmap last week and decide to pivot. Their foundational technology was built entirely in anticipation of this exact structural crisis. The public roadmaps we just walked through, they are simply confirming, in their own highly technical language, a bottleneck that shaped SisuSemi's research agenda well before this generation of documents was even published.
So if you're doing diligence in this space, trust the unvarnished signal of those roadmaps. Honestly, they're more convincing than any standard pitch deck out there. The industry experts have told us exactly where the hardest problem sits. The only question left is, are you going to be disrupted by the atomic scale bottleneck, or will you partner with the only company that saw it coming? For more information, please contact www.SisuSemi.com.